talk called What You Need to Know About Lambda, with all the excitement about Lambdas coming in Java 8. The usage of Lambda is going to become more widespread, and as a result, what I'd like to talk to you about today is my own personal experiences in using Lambdas for several years and things that can trip you up about them. They are not a free lunch. So, first of all, my name is Jamie Allen. I'm the Director of Consulting for Typesafe. We're the company that makes Scala, the language. We also make the Akka concurrency toolkit, as well as the Play web framework. And so we've been using Lambdas on the JVM for quite a few years now. And as a person who works with clients, you know, it's very frequent that I see people using Lambdas, especially for the first time, getting their feet wet with it. And it's, you know, it can be a little tricky if you don't understand the dynamics of Lambdas. So, I'm here to explain that. First of all, I want to be perfectly clear about this. I love functional programming. I don't want anybody to think that I don't love functional programming with what I'm going to tell you today. To me, functional programming is three things. It's immutable state. Not having mutable state in play inside of your application as much as possible. It is also referential transparency. And by referential transparency, I mean the idea that you performing an operation on some state that results in a new operation or new value doesn't change the original value. Has anybody here ever used Java's string builder? Anybody ever shoot their foot off using Java's string builder by doing something like reversing the string? What does it do? It reverses not only the value you get back, but also the original string builder string. So that's not referential transparency, that's referential opacity. We want to avoid that sort of situation. This is one of the reasons I'm not a huge fan of JavaScript. JavaScript doesn't do this well. And finally, functions as first-class citizens. Functions can be passed around. They are objects, they are types, they are values themselves. They're first-class citizens. That represents functional programming to me. Anytime you hear people talking about these fancy words like endofunctors or monoids or anything like that, that isn't necessarily functional programming. It's a way of functional programming. It's category theory. So, you know, that is not the key concepts of functional programming. This is what I love, and this is what I want to use in my programming. Now, Lambdas are merely an implementation detail of functional programming. They're one of the ways that you can write functional programming style code. A lambda is a function literal. A literal is just like a string. Whenever you have open quote, you know, foo or hello world, end quote, that's a literal, right, in a string. A function that is a lambda is a literal. It is just defined for where it is being used at that particular call site. It's not bound to any name. It cannot be referenced. It cannot be used in any way aside from where it is defined. So, implementation detail of functional programming. And I'm going to step out a little bit on a limb here, and I'm going to say not that lambdas are evil, but they can get you into trouble. First of all, let's look at what lambdas are on a couple of different languages. Here's Java 8. Anybody here play around? I think George just asked us. Anybody here playing with Java 8 right now? It's nice. You can download it, run it on your computer. Things work pretty well. It's pretty close to being ready. And the lambda here is merely me saying that I want to take a number, a collection of numbers and add 1 to every single value. It's silly, it's pedantic, but this is a lambda. You can see it here in orange. So the first thing I do is inside my public static void main is I define a list of integers, you know, arrays as list 1, 2, 3. And then I have the values that represent the changed values after adding 1 to each one of them by saying numbers. I have to streamify it. I then map over this collection. Mapping is a way of saying for every item in, do this. So for each number, add 1 to it and return that. I then collect that and put that back into a list. In Scala, we have a slightly different syntax. We can create an application without having to say main, merely by extending something we call the app trait. And I can define my numbers as a list of 1, 2, 3, and then I can map over them. And again, the Lambda looks virtually identical to what we saw here in Java. You know, this pointer thingy here, this arrow, this rocket, some people call it, is slightly different, but generally speaking, this is very similar syntax, right? Clojure. Anybody here ever program in Clojure? All right, there's one. Lispers think that this syntax is beautiful. Just want to point that out. Clojure is a Lisp on the JVM. And whenever you run a Lambda on Clojure, first of all, you have to understand with Clojure, it's a lazily evaluated language. So if you're wondering why I'm doing this print line here, that's because if I don't do it, it won't actually execute the code. You can do a print line before and after, and you will not see any result from this Lambda being applied. So this is how I'm forcing evaluation. And I'm mapping over every element and adding 1 to it. It's a little different, but you know, Lispers love this. So, and finally, JRuby. Very simple syntax here. You take your array of 1, 2, 3, you do a collect operation to it, and apply this do to do for every n, add 1 to it. These are very, very basic, very simple Lambdas. But in each language, you can see how there's a similarity to them. So what is the problem? First of all, this code is not reusable. There's no way for you to say with your Lambda that I want to take that code and use it somewhere else. Either you have to pull that out into some sort of external function or method, or you're going to end up being not dry. You're going to start writing code that is going to be in the same place in multiple places, or the same code in multiple places. And that's one of the worst things we can do as programmers, because if it turns out there's a bug inside that code, we have to change it everywhere that we put it. It's bad. We want to avoid that. They are not testable in isolation. Anybody here an adherent of test-driven development? Me, I'm not so much a TDD person. I am a person who believes in testing. I don't care if you write tests at the beginning or at the end or whenever. But if I write them and I prove that my code works and I have that ability to tell that whenever I change something that I've got regression analysis, I know that I haven't broken anything. I'm still meeting my functional spec. That's important to me. Lambdas don't let you do that. If you have Lambdas, this code only exists where you're using it. You can't reference it. You can't test it by itself. Now, when you're doing something as simple as adding 1 to every integer inside of your collection, that's probably not that big of a deal to you. But believe me, once people start using Lambdas, they get kind of crazy with them. It's very easy to start writing multi-line Lambdas that do all kinds of funny stuff. And when you do that, and you can't test that in isolation, you can only test that by calling some method in which it lives, you suddenly have a lot more test cases you have to write. Or worse yet, they get ignored. You're not covering all the edge cases of just that Lambda. Maintainability. One thing you may have noticed about the Lambdas I showed you earlier is that you had to look at the code to figure out what it was doing. Who wants to do that? Not me. I want to be able to just look at a method call or something that explains to me what the code is going to be, and if I need to, I can then go look at the method. And that will tell me, what's going on. I don't have to, parse through this mentally. So with Lambdas, you can't do that. You have to look through all the code, and the more complex they get, the more time you're going to be doing this. And if it was somebody else's code and you're stuck maintaining it, good luck. Lousy stack traces. So Lambdas, especially, whenever you're talking about languages that are not Java, right? We've had to sort of finagle our way through, making our languages run on the JVM. We wanted to add language features like Lambdas, But in order to do so, we have to meet the contract of what bytecode looks like on the JVM. And in order to do that, sometimes things look a little hairy. I'll be the first to admit this. Scala stack traces, especially involving things like Lambdas, can be difficult to read. And that's the same with Clojure. It's the same with JRuby to a degree. JRuby's pretty good about this, actually. So what they do is when you create these Lambdas, they do something called name mangling. These compiler developers have to figure out a way to just create something referenceable inside of the bytecode. And so they name mangle something to get something to call. And the stack traces that you see represent that name mangled stuff. Very difficult to read. We'll get a look at it later. Actually, we'll look at it now. So here is, this is Java 8. And with Java 8, one of the neat things about Java bringing this to their own platform is that they control the platform. And they can make their Lambdas look pretty darn nice. However, the stack traces, that is. However, note a couple of things here. In the Lambda that I'm running, I'm just dividing by 0. That's just a stupid way of making an exception happen that's inside of this Lambda. And I say, inside the stack trace, we see that my Lambda demo class is referencing something called Lambda $0. And then you look at the source line, and it says 1. What? 1? That's not on source line 1. It's going to be difficult to figure out, as you deal with more complex types of exceptions, and you have to look at much larger Lambdas that can be multi-line. It's going to be very difficult to figure out what it's talking about because it doesn't map directly back to your source. But this isn't just Java. Here's Scala. Remember what I said about how the stack traces can be a little difficult when you're dealing with Lambdas? Yeah. Here you see a case where I've got some Lambda test, and a non-fun is the actual class that was generated by the compiler in support of this Lambda. Now you do find out the exact line number of the source code where the Lambda was, referenced. That is correct, that line number 23. That will help you a tremendous amount because at least you know where it was. However, as developers, it's very easy to fall into the trap that, hey, I can write code in such a concise style if I just, put a whole bunch of things in one line. Anybody ever see Perl? Language Perl, and the things people can do with Perl. Sometimes you can do that with Scala. You can do that with other languages as well. Because you want to write something that's so beautiful and concise and pretty and totally not maintainable or give you good stack traces. To get good stack traces, you have to write your Lambdas a certain way. Every single line of code must be distinct so that you get that line number that is useful. If you write stuff and you just start stringing it all the way out some one source line, you're not going to have that because the JVM does not support anything other than, line number fidelity for where your error occurred. It's not going to tell you the column number. Nothing we can do about that. Clojure. You have to dig through here to find where your Lambda was because it's inside the language where the failure is going to occur. You need to find out what you wrote that caused the problem. You've got to look through here and find the exact point. And in this case, my Lambda is called fn__10. But the source line number is correct, and that's a good thing. And this goes on and on, by the way. The stack trace out of this is just, really, really, really deep. But at least you have the source line number. Very useful to have. JRuby, they didn't do half bad with this, actually. And maybe it's a function of me just doing something silly that they can say, well, that's an arithmetic exception. We know how to deal with that. Maybe if I did something that was a lot less pedantic, it would have been, much more verbose stack trace. But, the line number's correct. That's great. We want that. So Another part of this that is sort of related to our problems with stack traces is that this is also difficult to debug. The tooling for how you use a debugger with Lambdas can be dodgy. Depends on what you're doing. People who use Clojure, they typically aren't IDE kind of people. They'll typically write in Emacs, and more power to them. But if you're a Java developer and Scala developers, what we at Typesafe have really had to work to do is make sure that these are, Scala IDE support for how you use Lambdas, is good. Because it used to be that you would put a breakpoint on the line of code that was going to map over your collection, and then if you stepped over, you just went to the next line of code, which could be something, totally unrelated to Lambda. If you wanted to step into, you couldn't. You couldn't see the iteration. Now the Scala IDE does do that. It will show you the iteration. How many people here program in Scala or have programmed in Scala? A few. One thing I didn't show you with our Lambdas is that you can define a placeholder instead of saying numbers, arrow, numbers +1. You can just say underscore +1. If you do underscore +1, you can't debug that. You can't watch underscore. There's nothing for the debugger to say, it might be able to come up with a name for it maybe, but then do you know that that is the name that it assigned from the compiler or from the debugger? It did that, didn't tell you. So when you use these wildcard type placeholders, you lose the ability to debug, and the iterability through the collection can be tough depending on the IDE. So, a quick digression. How many people know the difference between a Lambda and a Clojure? This is one of those topics that, you hear people talk about Clojures. If they're in the Groovy world, it's sort of the general term for Lambdas anyway. But there is a distinction in programming language theory. Lambdas, function literal. Clojures mean that you're closing over external state. I am doing something where I'm referencing a value from outside the context of the Lambda. I'm closing over. Hence the name Clojures. Easy to confuse with the language Clojure. I have no idea why Rich went with that name, but makes for interesting discussions. So, closing over state is one of the biggest problems you can encounter with Lambdas. It is very easy to find yourself in trouble when you close over external state. Why? On the Java platform, in order to do so, you have to have a final value, right? You have to, just like we had with anonymous implementations of interfaces, if you want to reference something from outside of it, it has to be final. Great. That's awesome. Except, what if it was a collection? You could still change what's inside that collection, right? That's not immutable. That's not protecting you from shooting yourself in the foot. If you're referencing something from outside the context of your Lambda, in a Clojure here, you can very easily get yourself into trouble. Imagine if it's code that has to be thread safe. Say it's mutable state that you're referencing somehow, like that collection inside of your Lambda. Now you've got to worry about thread safety semantics inside of your Lambda. You can't synchronize it. Got a lock. No, it's not good. And even better, anybody here ever work with futures and asynchronous programming? Yeah, I love them. They're awesome. And in Scala, we use Lambdas to apply the behavior that's going to be executed, off thread. Great stuff, except race conditions can happen all over the place if you don't know what you're doing. You're closing over something from outside the context of the future. You have an expectation of what that value will be at the time you wrote the code, but the time when it's executed is not known to you. You don't know when that thread will be scheduled for execution on the box on which it's going to run. And as a result, race condition, very easy for the closed over value to be different than what you expect at the time the code runs. So be very careful when you're using futures and Lambdas. So what is the solution to all this? What are we going to do about it? We want to write code that is maintainable. We want it to be written in a functional style. Boy, I'm going pretty fast, actually. We want to write code that's maintainable and in a functional style, but we also want to have something that's going to be usable in production. When things go wrong, we can figure out what the problem was. So how do we do that? From this point forward, I'm actually going to be showing Scala because I didn't have time to do this for Java and the other languages, but it'll be very simple stuff. One option we have is named functions. We can say that we want to bind our what was a lambda to a name, and now it's not a lambda. It is a function taking arguments and resulting in some other value. That can be a good thing to do. It depends on the language, actually, and the way the compiler scopes the result. The implementation of the function in bytecode will affect how this results in stack traces and stuff like that, right? So if we use a named function, and here's an example in Scala, you'll note that the first thing I do is I have this value add 1 to value. That is actually a value. It's a function value. And I say that it takes some integer. I'm going to call it x, and I'm going to add 1 to whatever was passed in. And now, whenever I say that I want to map over my numbers 1 to 20, I'm going to apply this function to it. You know, for every value, add 1 to value. And this will work. One thing about it, though, the stack trace still sucks. This is on us at Typesafe and our compiler writers. We have to do this better. But as of now, if you look at this stack trace, you'll see that we still have our non-fun. Why? We named the function. It should be telling me that it's the add 1 to number, right? No, not in this case. So, given that, what do we do? Anybody ever heard the term Eta Expansion? Eta Expansion is the idea that you can take a lambda, and not a lambda, a function. You can take a method and lift it to a function, right? You can take any old method that meets the contract of how a function would be used, any method, and lift it to being a function. Now, depending on the language, this is either done at runtime or compile time, mostly compile time on the JVM, right? It's got to know that this is going to be something that can execute appropriately on the JVM. But Eta Expansion can be really useful for this case. We want to use methods as functions. In Scala, if we use a method, it can be lifted, just like I was saying. But what syntax do we use in order to make this work? Here I have taken my previous function, this bad function, which is going to do the, for every value divide by 0, and obviously it's going to blow up. All I've done is change what was a val to a def. And in Scala, that means it is now a method, as opposed to being a stable, immutable value. Now, if I look at my stack trace, I do see bad function. This is good. Now I have something that tells me where the error occurred, not just with the source line number, but also with the name of where the code is that caused the problem. That's fantastic. Except there's something about this code that's not really good. My bad function that I defined, because it's a method, it's going to be evaluated every time it's called. And I'm saying on the right-hand side of my equals here that I have some function, right? It is going to generate a new function every time I try to use this, this code. We don't want to do that. That's not a good use of resources on the JVM. Yeah, they're short-lived objects and allocations are cheap and all that, but why? Why do that? So we do want to stick with def, but instead we just want to use regular method syntax, not function syntax, and let the Eta Expansion magic work for us. When we use this bottom example here, where we just pass in some int as an argument to a method, and then we perform the behavior inside of our method, we get stack traces that are much more usable. You have to write code like this if you're going to deploy in production. I'm telling you this now. Know the dynamics of the language that you're working with so that you understand when things go wrong, how to understand and deconstruct the problem through your stack traces. So what are the benefits here? The benefits are we can't close over variables when we use a method, can we? We can't. We can call or use something that's defined at the class level. Don't. If you can avoid that sort of thing in general, that's probably a good thing. That's where you tend to run into thread safety issues, right? Whenever you define things at the top of a class. If you can keep them local to a method, you're going to be in much better shape. Internal variables are operands, passed in, as opposed to things that you're just referencing from somewhere else, hopefully. You get better stack traces. It's much more debuggable. You can put a breakpoint on the method. It doesn't matter that it got lifted in as a function. It's still going to break on that method. That's good. And it's more testable because you can just write unit tests against that method and make sure that the basic behavior that you were trying to put into a Lambda in isolation works as expected. You have easier maintenance. You now can look at the code and see that I'm calling this bad function as opposed to mentally parsing what was supposed to be happening there. And you have reusability. So rule of thumb, keep your Lambda usage to the smallest possible use cases, the smallest expressions you can think of. Yes, you can use Lambdas if you want to just do, add 1 to every value. Anybody can figure that out, and generally speaking, you're probably not going to have a bug there, right? Unless you have to worry about things like thread safety and yeah. But for those smallest examples, yes, go ahead and use a Lambda. You're not going to want to go through this process of using a method or something like that in every case. But know the threshold. Have an idea internally of what the threshold is where you want to say, all right, this Lambda is starting to get complex. I want to pull this out. I want to test it by itself. I want to have stack traces that are usable and be able to debug all this, right? Know that threshold. For me, if it's more than 1 line, it gets pulled out. As language creators, this is on us. This excitement about Lambdas can't be allowed to just wane. This excitement about functional programming, it's a really big deal. And we have to provide you with the tooling and the resources that you're going to need so that you can take advantage of this in production and not feel like, oh man, why did I go and use Lambdas? Why did I go with a language that's supporting this stuff that I keep hurting myself with? At Typesafe, we're very focused on what we call the developer experience. Anybody who's gone to our website recently, we have a new tool called the Activator. It used to be that if you wanted to start using Scala, you had to download all these individual tools or maybe use apt-get, whatever. It wasn't the greatest developer experience, and we know that. We hired somebody named James Ward who came into our company and immediately identified this as one of our biggest problems. And Activator solves this. Now we're focused on being able to get you up and running, building an application in either Play Framework or Akka. There's all kinds of templates that we're building for this, as easily as possible. The developer experience for what happens after you write the code, we all have to do a better job of. The language creators, be involved in your community, whether it's with the Java JCP process, the JSRs, whether it's in the Scala mailing lists, the Clojure mailing lists, the JRuby. Charles Nutter is extremely accessible. Very, very great guy. So be involved with these communities. Help them make you better with your Lambdas. Thank you. It was actually a pretty short talk. Anybody have any questions? Okay. Personally, the question is, can I talk about the IDE experience across the 3 major ones, such as NetBeans, IntelliJ, Eclipse? I can't, particularly from Java. because I personally use Sublime Text. I don't know if anybody's ever heard of Sublime Text. It's a really awesome editor. I'm a huge fan. And my experience with Java 8 is fairly limited. So I wrote my Java 8 inside Sublime, and I didn't use the debugger that's inside of NetBeans or Eclipse or IntelliJ. Now for Scala, I can tell you that the debugger support in Scala IDE, which is Eclipse-based, and IntelliJ are both very, very good. If you set breakpoints, you can step through your Lambda. But again, it's how you write your Lambda and what's inside of it. You know, if you've got multiple things on a single source line, which you can do, stepping is going to keep showing you the same source line for all the operations that resulted in that single line of code, right? The byte code is different, but the source line wasn't. This is actually something to think about anytime you're doing something that is metaprogramming or DSLs, embedded DSLs. If you're going to write something where the compiler is going to take liberties with your code to result in byte code that could be completely different from the source, they can be very difficult to debug. Because you've got the source, you've got one line, you're sitting there and saying step over, and it's just staying there on that one line as it goes through all the byte codes that it's got to, deal with for that single, operation you were doing that got blown up into a bunch of byte codes. So keep that in mind. The question was, how are methods exposed as functions in the Java context? How does Eta Expansion happen? I'm really excited. I got to meet Brian Getz this morning. He's a personal hero of mine. I'm a big fan of JCIP, Java Concurrency in Practice, the book he wrote back in 2006. And I asked him this question. I asked him, how is Eta Expansion going to be supported? And he said yes. So this is a good thing. You're going to be able to use methods, and they will be lifted as functions in Java. The implementation details of method handles and SAMs in the particular case of Lambdas, Alex is back there, I could see him. I hope I'm getting this somewhat right, but this isn't something I know deeply from Java 8. It's using method handles under the covers to represent this Lambda, right? And as long as you have a method that has a value, let's say one parameter, it can be lifted. I don't know how a method that has multiple arguments can be used for a Lambda, for lifting in Java. I think that he said that you could have multiple arguments in a method that's going to be lifted, and Alex is nodding, so that's right. I don't know how the values are passed as operands when only the first one represents the value from the collection that you're mapping over. So Alex is going to be giving a talk about Lambdas, I think tomorrow morning. Yeah, and he'll be talking a lot about the dynamics of how they're implemented and stuff like that. So he'll have answers for you about that.
Does that mean like when it's exposed as a function, other class member variables or other classes can use it?
When you define it as a function, I'm sorry, the question is, when you define a method, can other classes and other, can they use it? Yes, as long as the accessibility is public, right? And if you limit the accessibility, it's just like any other method, right? One thing that we tend to ascribe to in the Scala community is that we want to write code that's expression-oriented. We want to have elemental, atomic pieces of code, of behavior, in these small chunks that just return a value. They do one thing and return a value, do one thing, return a value, and then build up from these libraries of expression-oriented functions, more complex functionality. It's very reusable and very testable. As you add them together and start building things, it does make your tests a little more complex, but they would be anyway if that was just one method doing all those things, right? So, but having those in little itty-bitty pieces, makes a big difference. I would assume it's the same way for Java, maybe a little more verbose, but you still don't want to have big, long, complex methods, right? You want to have small ones. The question was, I mentioned that I'm not a huge fan of JavaScript. I mentioned it has some issues with the way it does functional programming. So could I elaborate on that? And I'd rather not. I will say this. Referential transparency, as I described, JavaScript, you have no guarantees of that. And it will be interesting, actually, when we talk about Nusshorn. I've been saying it wrong all this time. I have to make sure I say it correctly. It's good to know that, where that word came from. It's going to be interesting to me to see how the dynamics of JavaScript are maintained on the JVM. Is this lack of referential transparency going to be included in the implementation on the JVM when everybody knows that it doesn't make any sense? The fact that I'm operating on something shouldn't change that value if I want to result in something new, right? If I'm doing something to get another value, should I change what was there in place? I don't want to. I never want to do that. Rich Hickey, the creator of Clojure, has this really great way of talking about value versus identity, right? Value is the point in your heap where the value exists. If you have a number 5 that's in your heap as an int, or an integer, that is the value, right? You never want that to change. The identity, what is the name of that 5, whether you call it foo, whether you call it myint, whatever, you can totally change that to point to other places. But you never want to change that 5, because what if somebody else is relying on that 5 being that exact memory space? That's how you get yourself into concurrency issues, right? So value versus identity. JavaScript is terrible about this. Okay, well, thank you very much.